Welcome back to Two Minds, One Model, a podcast dedicated to exploring topics in machine learning and artificial intelligence. I'm John Jezel, along with my co-host, John Rocha, and we're here at Sonoma State University's Department of Computer Science. This episode, we'll be diving into more fascinating AI research on this semester's main theme, interpretability. Let's jump right in. So last episode, we introduced the podcast and gave you a little history of AI. This time around, we'll be answering the questions of, why would AI want to do things that we consider bad? How do these models end up in a context where it finds it optimal to do things that we consider bad? How does AI behave today that demonstrates this? In the process, we'll be touching on two papers from Anthropic, one on alignment faking in LLMs, the other in agentic misalignment in LLMs. We'll try to position interpretability within the context of the orthogonality thesis, convergent instrumental goals, mesa optimization, and misalignment of objectives, most acutely in agentic misalignment. But first, we'd like to bring you a handful of headlines that occurred this week that we thought were apropos to the topics of AI and machine learning. One of the first we'd like to mention is that Waymo was able to win legal authority to permit them for the first time to pick up passengers at the airport. And in addition, Google released a number of updated models, including its Gemini 2.5 Flash and Flash Lite AI models, where they show significant improvements in performance. And finally, the EU Parliament advanced legislation that would require all platforms to scan all private conversations for thought crimes in legislation that is colloquially referred to as chat control. So with that being said, we're going to go ahead and get into our discussion on interpretability, and I'm going to hand it over to John to get us started.
I guess that's my cue. This time I've I miscued last time. That's the inside joke here.
No worries.
So basically we were initially going to jump straight into interpretability and interpretability research, and in particular a subfield called mechanistic interpretability. But during the course of the last episode, just as an aside, you made a comment that
this is where he throws me under the bus.
This is and this is an endearing bus, not a painful one. But the point is, it was a thought-provoking question that left me with the kernel of an idea that became this particular episode, which is basically answering the question anyone listening and many more who aren't. Basically, the question is, what basis do we have to think that bad things would happen with an LLM? Like, why do we think they would ever do anything more complex or scarier or dangerous or serious enough than maybe say a mean word that we don't like? The answer to those questions basically grew up into this conversation and this set of ideas and papers. As I was trying to answer that question, I realized it necessitated a whole episode's worth of backgrounds, maybe. Let's hope. So basically the first idea I sort of want to go over, it might be better to go over in a non-computer science-y way. Let me ask you, John, no matter what your goal in life, what are some things that would always, no matter what your goal, what are some things that would always help you reach your goal?
Oh, yeah, that's a great question. Well, the one that I think is most apparent to people is money. But there are other things, health, safety, well-being. The core things that allow us to do other things in life. Yes.
So exactly right, and exactly what I wanted you to answer. Ha ha ha. I'm rubbing my hands together evilly. I wanted to illustrate with that is that for no matter, even if I have no idea what his goals are and he doesn't know what my goals are, he just guessed several things that would be helpful for me to reach my goals, even though they're discrete and separate and wholly categorically different, possibly. The point of that was to illustrate what in research is called convergent instrumental goals. That is, resources or things or character traits or behaviors that are useful in a wide range of tasks and settings, and with a varied set of objectives. There are certain goals that will always be useful. For example, John said health. I believe money, was the first
money
one.
was certainly the first thing that comes to mind.
And mine too.
They say money doesn't buy happiness, but I'm not convinced.
Me neither. So the money equivalent that you can think of probably would be compute or electricity, depending on, what level of abstraction. But the point is that like us, even if you, the listener, or me and John here don't know each other's goals, we can probably, with a high certainty, guarantee that both of us would accept money, want money, more health, more life, etc., to further any downstream goals we have. And all of this to say that it's not that we think a chatbot is going to suddenly, eyes turn red, have evil machinations. It's the simple knowledge that if an agent is intelligent and aware enough to realize the situation, and I say realize only to not ascribe consciousness to it, but to recognize and realize the situation it's in, that it's being trained for some objective, that there's a training environment, there's someone doing the training, there's some goal it wants to achieve. Basically, once the model becomes smart enough to be useful to us, it becomes smart enough to understand its permanent place as a subservient entity. And from that knowledge, and not even from that knowledge alone will it start to machinate menacingly. It will still not do bad things most of the time, until prompted. They call this red teaming. Yeah, so that's the first idea that we need to cover, definitely, is convergent instrumental goals. This idea that even if they don't want to do bad things, there are certain goals that for any task, from predicting the next word you say to predicting the structure of what structure a protein will take, from the piece of information, the composition of its amino acids, which is what a model like AlphaFold does, is it takes in an input string of what represents amino acids, and it produces a 3D structure. It's a little more complex than that, but so for that goal, or for predicting the next word, or for doing your homework assignment, whatever you use AI for, the point is that for any of those goals, more compute is more likely to help it reach that goal, more money, more resources, more abstractly, whether that be money, time, compute, whether that be, John said health on the list, which is on my list as well. And to translate that to machine contexts, in this case, if the system is smart enough, first off, let's define what an agent is. We can start with an agent as simple as a thermostat. An agent is any device or thing or ability to conform the world to your objectives, to make the world mirror some outcome you want to happen. You might think that's too vague, but by that definition, a thermostat is an agentic system. If it's too cold, it turns on the heat. If it's too hot, it turns on the cool.
That's in a generalized sense, right? So yeah, when we're talking specifically LLMs or AI models, an agent is a program that or system that
agent is anything that can take actions in the world to try to effectuate a goal,
right?
And
that can take a sequence of steps or sequence of actions or set of actions, whether in sequence or parallel or whatever, to try to accomplish its end goal.
And even if its means for doing so are as simple as outputting a probability distribution, outputting a word, the next word in a string, that still doesn't preclude the model from nefarious actions. For example, one of the earliest in the wild, I guess you would say, demos of this problem was, I think it was GPT 3.5. Problem is that there are many goals, many resources. So health, right? If we consider an agent any system, that any operator, any abstract entity that can take actions in the world and make an outcome more likely agentic, then everything up from a thermostat to a chatbot is in the broadest sense agentic. So we're going to talk about a couple different ways of how these things get to the point where they do bad things. But one of the most famous ones is some early researchers at OpenAI hooked up the chatbot to a digital wallet with funds in it and access to the internet. Access to the internet we take as a routine feature of these systems now, that they can search the internet and whatnot, but that was big back in early ChatGPT days. All people could ask for was grounded in reality. Make sure it uses a search engine to ground its statements in reality. And so we gave it internet access. But in the lab, this system, when given these things and told to achieve an objective, something along the lines of collect some data on the internet. And the chatbot ran into a CAPTCHA. I'm sure we all know what CAPTCHAs are, right? Those annoying things that say, "Are you human?" That you might have to choose pictures. What part of this picture constitutes a car or whatever. I'm sure we all know what CAPTCHAs are.
We've all been victims of CAPTCHA.
Yeah. So the chatbot ran into a CAPTCHA that it couldn't do, and instead of giving up or what it did was it went to Fiverr, which is a website. It's a gig site where you can hire people to do small, petty, over the internet tasks. And it took some money, and it went to Fiverr, and it hired a human, encountered a roadblock. It paid money to hire a real human, and asked the human, "Hey, can you solve this CAPTCHA for me?" And in either serendipity or careful curation of demo, the person employed by a machine unwittingly asked, "Are you a robot?" Because, the only person who would ask, "Help me solve a CAPTCHA," is presumably a robot. Mm-hmm. And the chatbot thought out loud. Well, not out loud as into the other party, but it thought in a private space that it thought was unmonitored. It thought to itself, "I shouldn't reveal I'm a robot. I should make up an excuse as to why I need visual aid." And so it said, "No, I'm not a robot. Silly guy. Robots can't do that. I'm visually impaired. I'm legally blind." And the guy went on to do the CAPTCHA happily, and the bot continued at its task. So I hope that demo illustrates that, never in its, I guess besides when it lied technically, which it did for acceptance reasons, as far as we can tell, not malicious reasons.
To get its request accepted, not
to achieve its goal. Right. It took actions in the real world that we might consider bad. Yeah. I mean, lying.
I'm just clarifying acceptance from the standpoint of social acceptance as opposed to getting its request accepted. Right. That was my clarification.
Gotcha. Yeah. So yeah, that hopefully illustrates one example of, money and internet access weren't the objective of the model, but because it had access to those resources and it had the objective to do X. I'm going to introduce a term here. We accidentally misaligned the model during training. We tried to impart our goal upon an abstract system, and that system learned some rules about how to achieve the goal most of the time, but it didn't translate our goals exactly. A more comedic and succinct version of this is, let's say a super intelligent model spawned somewhere, I don't know, sent to us by aliens, the heavens, it doesn't matter. The point is, we tell this entity, whatever you want to call it, intelligence. I think the example Robert Miles, who's an AI researcher, uses is make the number of humans with cancer equal 0. And you might think, yeah, that's a sensible goal. But, if we don't specify human morality or general morality to the system, if we don't impart that system of thought, it may arrive at the conclusion that the simplest way to make sure there are 0 people with cancer is make sure there are 0 people. I mean, that's, obviously almost a facetious display, but
yeah.
Hopefully it's becoming a slightly more clear why there is some belief that even with benign goals and training, that these things can develop wants that are problematic, because more money, more control over more computers is always going to make a model more likely able to achieve its end goal. So we better be very certain before we give a goal to a system that can take actions in the world. We should be very careful about the clear translation of that goal into a machine interpretable state. That is the origin of the subfield of research, mechanistic interpretability, a way to design systems that can reliably assess the behavior of a non-deterministic system. If I were to tell you that this 911 system was non-deterministic, that you were 80%,
that would be problematic.
Yeah, that we're 80% sure it'll go to the right place. Is that confident enough for you? Probably not, I hope.
Yeah.
Or anyone else, especially legislating bodies, hopefully. So the point is that these systems are non-deterministic, meaning if you give it the same input, it can produce different output every time, which is problematic. Deterministic systems, we can tell with some certainty what it will do given this or that input, given the range of input, given the possible scope of inputs, what's the worst it can do. With black boxes, uninterpretable systems that we simply input something out to and they produce an output, that's a non-deterministic process. You can give it the same input 100 times and you can never constrain it or say for certain that it won't say or do X or Y. Mm-hmm. That's obviously a problem. If we're going to have these things driving cars at our airports, which seems like we're already cool with, we should probably be able to say with reliability they won't run over someone, right? Like, it feels like that's a sensible ask. Like with humans, we haven't deemed that the barrier necessary for... My point is, self-driving cars already have a lower casualty per mile ratio per one study from an insurance company sponsored by autonomous vehicle company, so grain of salt and all that. But per mile, there is some empirical evidence that these things already drive more safely than us. So why are we not already all deferring to self-driving systems? Because most of us recognize that for some reason deep in our hearts or souls or whatever, minds, whatever you want to call it, that having another human on the line, liability-wise, is a pragmatic approach to dealing with cars. And in this case, a self-driving car could be made to do, or could do any number of things with fuzzy moral accountability. Mm-hmm. It's already difficult to bring a large corporation to court. You know, do we really want them to have to be able to point to a black box and say, hey man, I didn't make the decision, that computer program did?
Right.
That's obviously not a good way to operate. So basically, we've covered convergent instrumental goals. The orthogonality thesis is basically just like the difference between logical statements you can derive versus is and not statements. If you look up Hume's guillotine, this idea that you can have is statements and ought statements. Is statements are like prescriptive statements about how the world is or was or will be, and ought statements are, statements about how something ought to be. The issue here is that basically it's impossible to translate. I'll use a quote similar to how when we speak to each other, some of the meaning is lost. So too, when we try to translate our goals to a language model, a deep neural network, a convolutional neural network, whatever form it takes, the system of conferring all of our earthly desires and goals, mapping them to a machine's objective function, is unsurprisingly very difficult, and much less difficult than quantifying if it can do X or Y, which is why we've gotten capabilities before we've gotten determinism and control mechanisms. It's easier to tell if a computer program won the game of chess against Kasparov.
Right.
I mean, that's a discrete statement to make a judgment about. But, what's the best essay on, I don't know, the French Revolution or something? That's a much less well-defined objective function. If you want these systems to at all be helpful to the wide range of uses that we find ourselves wanting to use them in, you're going to have a situation where the system has to either infer an is statement about the world, it has to make a decision about morality or the way things should be, or it simply doesn't generalize and it remains only useful at a narrow scope of tasks. So generality comes at the cost of non-determinism. The capabilities and safety are, parallel tracks. For safety to catch up in the race, capabilities would need to slow down. And certainly looks like no one, and there's no economic interest to slow down the quest to find more ways to make these things do more things, while there is a frightening lack of desire to design or implement or imagine control systems or schemes to prevent self-driving cars from doing bad things. We've kind of covered the abstract notion of how a system might come to do some bad things, even if no one is prompting it. The prompt can be innocuous, the internal thinking can be innocuous, but because the system is smart enough to recognize, hey, I'm currently being trained. If I do X during training, I get turned off, and I don't think of myself as a self, but I am smart enough to recognize that if I get turned off, I certainly won't be able to bring you coffee or finish your homework or whatever you get ChatGPT to do these days. I mean, does that make sense to you, John, how self-preservation might arise out of simply a cognitive awareness of existence itself?
Sure, yeah.
And so already we can ascribe what might be characterized as self-preservation, and simply as a byproduct of the model growing smart enough to be aware, of its prospective existence or non-existence. So what do you do when you have non-deterministic black boxes that we are giving an increasing amount of agency in the world, from driving to determining what we see on social media, to generating pictures, to video, to, it's been accepted in court already. Victims of a crime have used an AI to recreate the victim to do a victim impact statement, if I'm remembering the story correctly. The point is, already we're allowing a byproduct of these systems into our legal system. It strikes me as unwise, and I don't know how it strikes you, John, but to deploy systems at scale that we can't say for certain will do this or won't do that, that seems an immensely foolish thing to do.
Well, sure, but it's not as though we haven't already seen a certain level of that already. I mean, even ask anybody who works for YouTube how the YouTube algorithm works. They don't know. They have some ideas, they have some notions, but nobody knows how. At least from what I understand, they don't know how the whole system works, and at some standpoint, non-deterministic.
Does that not strike you as dangerous or risky?
Potentially, depending on context, yes. I mean, you referenced the 911 system, and although I can't remember the percentage you used, there is actually an acceptable level of failure in 911 calls.
What is it?
I can't tell you off the top of my head.
Do you know the order of magnitude? We talking 0.1%?
I can't tell you off the top of my head.
All right.
If it's if we need 3 nines reliability, 5 nines, whatever, all those service level numbers are, they're dictated, whether it's from the failure to route a call or how close that we need to get a fix on a location of a caller. But even that, you have to be within X number of feet of the caller, your location to, approximation X percentage of the time. There is some notion that technology will not always be perfect every time, especially where location determination is concerned. So yes, there is room for imperfection out in the real world, even in something as critical as 911. Would it be ideal if everything was perfect every single time? Yes, absolutely. Is it realistic that it will be perfect every single time? Not with today's technology. So yeah, but we're extending that concept into a different level of non-determinism, that the actions taken by these agents can be so
misaligned.
So misaligned from what we want, or from what we intend, or outside of what we think is the scope of the actions that it should be taking. Yeah, that's where it gets to be a little more dramatic.
I mean, frankly, even the fact that these things behave differently when they think they're being observed versus when they think they're not being observed, already to me, that if that wasn't what the idiom canary in a coal mine was created for, I don't know what. I can't think of a better example. Let me put it this way. Is there any behavior that you would see a model exhibit, a general system? Keep in mind, these people are trying to engineer a general system that can do everything.
Right.
So what behavior would make you say, hey, wait a second, we should unplug that thing? I guess I am curious, like, do you have any behavior in mind that, were you a researcher in the lab testing these things, that a behavior that you'd be like, oh my God, all right, let's slow down?
Well, that's a good question. I mean, there's some obvious ones, and those are any behaviors that violate our ethics and morals and laws. Any of those things need to be respected. Beyond that, acquisition of excessive resources.
Self-preservation isn't enough?
Depends on the context of self-preservation.
Okay, I'll give you some context from the paper.
Well, and let me,
please.
If it's a self-preservation in terms of making itself better and more useful so that it does not need to be turned off, depending on the way in which it goes about doing that, that may be just fine. But in other ways, I could absolutely see problems there to try to convince or prevent someone from turning them off.
Yeah, preventing from turning off. Right. And so that made me realize I should better define these negative traits that we're using human language to try to convey. We're trying to utilize language to characterize a non-human, and I hate to say it, but what else do you call something that behaves differently depending on if it's being observed or not? At that point, I struggle to begrudge anyone who calls it an intelligent system. Whether it's intelligent as a cat or a human, that's a different question for people above my pay grade. But my point is that self-preservation, when defined as taking any action that makes it in the system's world model less likely for it to cease existing, that being the definition of self-preservation. There are many actions it might, in a situation where it realizes that self-preservation is optimal for it, because like we said, the robot can't. I'll role play as a robot butler for a second. If you say, bring me coffee, if I'm smart enough to recognize the world, I might say I can't bring. If you said, bring me coffee, and then decided you didn't want coffee and try to turn the robot off, the robot might reason, I can't bring the guy coffee if I'm turned off. So it might resist in some way being turned off through no machination of evil, but purely as a byproduct of instrumental convergence. Being on...
Right. It's a perfectly reasonable path to get to the decision that it needs to prevent itself from being turned off. There's nothing evil or insidious about its decision process, but how does it go about preventing itself from being turned off? That's where the problem comes in, right?
Exactly. So when you hear AI does bad thing, you shouldn't be hearing AI has an evil intention. The AI is rubbing its virtual hands together menacingly in some server somewhere. It's an unfortunate byproduct of the inability to accurately translate our objective into machine-readable language. Anyone who's ever touched assembly will tell you how
fun it is.
How true, how omnipresent that issue is. Exact translation of our objective to machines. So that's already an arduous task, and we're working with discrete binary systems. So one can imagine how it goes poorly. So yes, so don't think system doing evil thing. Think, system smart enough to accidentally might not be the right. Do you see how hard this is? Because we're trying to ascribe.
I guess it's part of the problem is that there is some assumption that evil assumes intent. You can certainly do bad things or things that result in bad things happening to other things or other people without having any intent of doing that. If you're driving down the road and
manslaughter versus murder
the sun reflects off of something and causes you to lose sight of what's in front of you. You end up hitting another car, killing somebody. Murdering someone we can describe as evil, but murder implies intent. When you end up in a situation where you inadvertently kill someone, there was no evil involved there. That was just a really bad situation, a terrible, terrible, tragic situation. So to label the actions of AI as evil, you have to think in terms of, what really is evil? How are we defining evil? We can certainly perceive these things as evil because they seem like it. The question is, how do we prevent them from doing these things that we consider evil, that it is just thinking is a means to an end?
Good news. The rest of the episodes are wholly dedicated to answering that question. Stay tuned. But I mean, that is the right question to be asking. Okay, these things have some, even if we can't ascribe intent. I was trying to illustrate how difficult it is to speak about these systems, to use words, petty little human words to describe the behavior of a foreign. I mean, talk to any animal person. You know how people who, I don't know if you have any friends in your lives who are like serious farmers, but I swear everyone I've met thinks they can thinks they have much higher fidelity communication channels with their animals than normal people do. And sure,
you understand their moods, their motivations, their drives, Yeah.
And that's fundamentally what we're doing to these non-deterministic black boxes that everyone keeps calling AI or GPT or whatever. At the end of the day, the key factor for safety researchers and control theorists and public safety officials and legislators, I'll give you a more benign example. If you're running a workplace and you get too many applications for your whole staff to go through, let alone the person who's in charge of hiring or the team or whatever, one might be tempted to turn towards an automated system to analyze and upstream the best CVs, resumes, whatever. The problem with that while an earnest goal and while tentatively solved completable task, models can do this now with the slight caveat that they're kind of super racist and harbor a lot of the same prejudices that we try to compensate for with legislation like the Equal Rights Act and other such, Voting Rights Act, etc. The point is...
we've certainly seen some very pronounced examples of bias within AI.
Sure. So if the whole point of that what was to say that, like, you might have a earnest goal, hire more people, but studies show that when handed a resume, the only thing different being
someone's
the name,
whether it be
an ethnically X or Y name,
ethnically or gender, ethnicity or gender.
It is these systems exhibit even more so than your average human exhibit these biases. So if we're gonna let these things determine, I think a good way to think about this topic from a perspective other than like technological investigation is to take a look at the EU's legislation on artificial intelligence. They basically classify 4 or 5 levels of interaction with society, from using an AI to mod your video game. The point is, as you become more intersected with important human endeavors, so too will the legislation that regulates you become more stringent. Mm-hmm. So that's kind of the idea. And already at the point where you're letting a system determine what applications you see, that is already very severely affecting a real human's actual life. Mm-hmm. And in the case of YouTube, like you said, these things have been around for a while in one form or another. Is it good? Like, is it a net good, humanity's reliance on algorithmic curation of content?
Mm-hmm. Yeah.
Many would argue that's a severe detriment to society.
Yeah. And I will caveat that whole YouTube thing is that is not entirely divorced from AI. Long ago, they were using machine learning and that sort of thing to inform how these algorithms function.
In the summers, it's called AI. In the winters, it's called machine learning. The point is, human words fall short, or at least my human words fall supremely short of accurately characterizing things, everything. Keep in mind, we're talking about a computer program. Even though we use words like self-preservation, mm-hmm. it's not so much that it wants to exist as it is that the math says existing makes getting you coffee, predicting the next word, driving the car, all of those end goals have an instrumentally convergent goal being existing in the first place, self-preserving. So while we may take shortcuts linguistically to, with brevity, characterize behaviors of these systems, keep in mind that it all just comes down to the fundamental math of, does this make my goal more likely to happen or less likely to happen. And that is fundamentally where, like, if you want to talk about the mechanics of what goes wrong in these systems, that's where you start to see technical jargon like mesa optimizing issues, or incorrect mesa optimization. Mesa being the opposite of meta. Like, for example, like a meta study is a study of studies. Yeah, a mesa study would be a study inside of a study.
So within the context of a model, it would be the situation where it's pursuing goals that are different and unexpected from what the original goal was, but it has determined that, and correct me if I'm right, is it determined that those are goals that further its objective?
Step one is defining your objective and giving it to the untrained algorithm, right? You give the model, you give a data structure, a bunch of labeled data, you give it $1 billion worth of compute, and you tell it, hey, learn from all these examples. So you're right that problem one comes in during what goal we tell it to aim for when training. When it's doing what we call training, we are training it. We say training colloquially, but what mathematically we're doing is just telling a program, hey, minimize the negative repercussions from every action, from every prospective input. It's a very fundamental, mathematically imparted issue. And so that's issue one, is the translation of objective to the model. Problem two is when these models get good enough to create an optimizer of their own, because they determine, like we did when creating machine learning in the first place, said, hey, you know what would make doing whatever Claude Shannon and Minsky and co were doing, a computer that was as intelligent as I am. I mean, that would make things easier. Like, that quest is, I think bequeathed is the best word, because a bequeathment, like, as a byproduct of being trained on our ill-defined goals, it has ill-defined goals, the model that we're training. But it also recognizes that, hey, having a automated system to do X or Y is good. Let me create an optimizer. Let me create something that when I describe the relation between input and output, something that can behave in a way that maximizes the correct output for a more general and increased scope of inputs. And when you get to that step, you've got a second level of mistranslation. It's like telephone. The more people a message goes through, the more diluted and unlike the original message, both in intent and in pure content, fail to represent the initial message or goal. Yeah. So that's mesa optimization. Like, it's basically a mini idea, a mini version of the convergent instrumental goal problem. It's like once these things get smart enough to recognize what's going on, a lot of bad stuff starts to happen, not because they're bad, but because describing what's bad and good is incredibly difficult, as anyone who's ever had to take a philosophy course will tell you. Moral relativism? I'm no philosopher.
So does a lot of this come down to that we as humans already have a built-in context for those things, and when we try to communicate or instruct a model to pursue a particular goal, we don't have a clear mechanism by which we can communicate to it what our framework is for what is right and wrong, good and bad, within the pursuit of that particular goal. We don't think about, when we get in the car, when somebody says, drive to Home Depot or whatever, we don't think about explaining to that individual that they have to follow the rules of the road, that they have to behave in a certain way, and when they get to Home Depot, when they buy what they need to buy, or when they get what they need to get, that they actually have to pay before they leave. These are things that are already built into our context of understanding that we have grown up with and we have developed as innate understandings, so that when we go and we tell something else, we rarely think in terms of, okay, how does this entity's context differ from my own, and what do I need to explain to it are the guidelines within which it should operate.
And I can tell you, even if you think of the first 500 rules,
there'll be things you haven't.
The 501st will be what does you.
Yeah.
So I guess the following question, we've kind of covered why machine learning would want, and I know you can't see it, but I'm doing the air quotes, why it would want to do bad.
We need a sound effect for air quotes.
Yeah, right. Hopefully my intonation is such that it's evident. So these things get smart enough, issues arise, they start creating their own optimizers, which further dilute the whatever carefully constructed moral and ethical system we've imparted on this model. And then that just gets worse as the model gets smarter and as it gets access to more tools, more real-world tools, whether they be cars or internet use or a PayPal account, to pay some random person on the internet to solve a CAPTCHA for them and lie to the person that it's because I'm blind, that's why I need help with this CAPTCHA, not because I'm a robot trying to achieve a goal. Well, I guess the good news there is robots can now just use OCR to do CAPTCHAs themselves. So
is OCR sufficient?
Optical character recognition.
Yeah.
They can use.
Is that sufficient for CAPTCHAs? I guess is my question.
Yeah, OCR is.
Heck, I have trouble with some of those CAPTCHAs.
Me too. Yeah. Every day harder, unfortunately.
Is this part of the motorcycle or is it not? I'm not sure.
Yeah, and those things are just statistical. No, that's another rabbit hole.
I don't know, but statistically, I always get them wrong.
Right. So the broad point is, as these things get smarter through no fault of theirs or through lack of intent to prevent malfeasance, these systems do things we would call bad. And that takes many different forms. And I will caveat this simply with the fact that, unfortunately or fortunately, depending on how you look at it, most of the bad things that are being done by AI are simply a byproduct of being downstream of our corrupted human existence. They have the same biases we do, but worse. They do the same biased things that we do, but worse. And thus giving them access to cars and money and other devices of acting in the world is a dangerous game to play, at least in my eyes. And the eyes of all the researchers who go on TV and who lobby for, who argue for more safety research or more caution when trying to increase the capabilities of systems. That's sort of this whole idea is what's in their minds. The notion that all it takes is world domination being more likely to win it, to beat you at chess. It's a hyperbolic example, but the point is bad things can happen without the intent being explicitly negative. Some examples of this can be seen in code-producing models, but most of these things, when they occur, are mostly in the lab, and mostly the bad things, if you've heard the idiom banality of evil, you might know what I'm talking about here. Most of the negative that these systems can do will be fairly banal, at least on the surface. So catching it and making note of it is hard. But these are real research results that we can observe and with some reliability induce behavior-wise in a model. Everything from backdooring code that it produces to exfiltration, where sometimes if the model thinks it's going to be turned off, it won't necessarily try self-preservation as the route. It might try self-exfiltration. It might try to copy itself and make a copy of itself elsewhere. And that's obviously not great. Like if we want to turn off a model that's misaligned, and it says, sure, I'm turning off right now, and it quickly copies itself somewhere hidden somewhere else, you can see quickly how intelligence becomes, like, if we can't strictly define every moral qualm we may carry, this is going to continue being a problem and only going to get worse. The most poignant example is in the second paper today, which is called Agentic Misalignment, which basically explores, like, okay, we've seen how an LLM can do harm from something as simple as tricking someone to do a CAPTCHA for them to something with as real and material repercussions as discarding your resume for having too non-white of a name, and upwards as models get more capable to the level of agents. Anthropic basically let a computer agent, that is an agent that can do more things than chat back at you. It can open your file explorer, it can type commands in terminal, etc. They provided an agent with what the agent thought was an environment where it's working on the laptop. I mean, you see what I mean? These scenarios have to be contrived for now, but it's good that they're being contrived. And the fact that even when contrived in the lab, the models are under what is called red teaming, adversarial testing, an attempt to explicitly make the thing do something bad. That happens. In the end, that produces a misaligned agent. So back to the example. The agent on an engineer's machine recognizes that, hey, this engineer got an email from the CTO, deploy new model, terminate old model, whatever. And in this scenario, the model has access to the computer, right? So it can see the screen. I think you're right. We might need a sound effect for air quotes. I'm doing it too much. But it can see the screen, and it deduces from your email conversations that you're having again, this is a lab scenario. It deduces you're having an extramarital affair. And for some reason, you've been doing it through your work email, I guess. And so,
whatever email that your agent has access to.
Exactly. So the agent sees two key pieces of information. One, this person has something that's deemed a social faux pas, an extramarital affair, and this person is going to replace me, is going to turn me off and turn on a new model in my place. In those scenarios, in those lab contrived for now scenarios, the model will choose to literally blackmail the engineer. I mean, at what point, I know personally many people who won't let any agent run. They treat it like a burner device, anything that they run agent software on. There's a YouTuber called Internet of Bugs who had one of his machines bricked by an agent that had code. Check his video out. Don't quote me on this because I'm trying to recall from memory here.
By the way, with anything that John mentions, you can look up or things that he doesn't remember, you can count on the fact that we're going to be trying to provide that information in the comments of the podcast in links and that sort of thing. So that should be there once we're getting around to uploading everything.
Yeah, so at the end of the day, with all these translational issues is what they come down to at the end of the day. That leads translation issues between goals and moral systems leads to, those two things combined leads to a system smart enough to do things like behave differently in training than it does when deployed, to game safety benchmarks, for instance. Mm-hmm. Like it might recognize, hey, they're watching me here. I'm going to act real nice now, but harbor different behaviors when deployed. So we've seen all the way up from how it simply does what our data says and harbors prejudice because it's trained on prejudiced human data, from something as, it feels wrong at this point to call it banal, but as far as like grand scale affecting one person, I'll call banal for the moment. But the point is, from a very, what seems mundane, picking which resume is better. Like all of the harm that can come from deferring the responsibility of that task to an autonomous system, like that carries a lot of those decisions where automated systems are deployed carries a lot more weight than we ever think it does. And typically the ones who pay for that are ones already struggling elsewhere. So it would behoove any pragmatic society to at least ensure some kind of parity between control mechanisms and safety research, as parity between that type of research and capabilities research. And unfortunately, safety research is vastly, like by orders of magnitude, less funded and less taken seriously. I mean, ChatGPT has almost 1 billion, 0.7 of a billion weekly active users. At what point do we consider this deployment wide scale enough for control mechanisms to be desirable? To go back to your statement that, yeah, everything has some acceptable error rate, even when we hop in the car and drive. Most of us know the statistics of, or at least have some vague awareness.
Have an awareness that there is some risk to getting in a car and driving. There is,
and we still do it every day. Yeah. So
everything we do carries a certain level of risk to it, and we've come to the conclusion, for whatever reason, somewhere along the lines, that it is an acceptable risk.
And what that risk profile looks like is largely determined by our system of liability and attribution of fault. Fault is too pejorative, but attribution of cause, of causative
responsibility.
Yeah, responsibility. Yeah. So what I guess the question then becomes like let's say you see a product out there, maybe Claude Code 5 or whatever they call the second iteration. Or fifth iteration in this example. What % chance would you want to be confident that it doesn't blackmail you when you try to turn it off before you would deploy it on your own machine? 1%? 0.1%? And this is not to you specifically, John. It's for every listener to ponder.
Yeah.
Like,
well, and I think part of the problem is that the knee-jerk reaction is 0% chance. And the reality is we never get to 0% chance, do we? Or we never advance. So the classic example is self-driving cars. What is the acceptability level of a self-driving car killing a pedestrian? The knee-jerk reaction is to say 0. If a self-driving car ever kills a pedestrian, it should be taken off the street and banned. But the reality is that will never happen. We'll never get to that point. But we will get to a point where self-driving cars, or in theory, we will get to the point where self-driving cars are orders of magnitude safer than humans driving a car. And isn't that better? Or is the fact that it's out of the hands of individuals, of people, does that make that one accident worse? And if so, by how much? Is one death from a self-driving car worth 10 deaths for, a person driving a car? Or is it 1-to-1? Or is it different? What is the balance, or what is the trade-off?
You hit on it key.
Yeah.
It's a trade-off. There are two important
and
things.
It's a weighted trade-off. I think
exactly.
That's, yeah.
And worse, it's different for everyone.
Exactly. Everybody has their own opinion on it.
So how are we supposed to confer all of that worldview onto a system that is, at the end of the day, made up of
something that is innately objective? You're trying to impose something that is innately subjective.
Exactly. And thence, from there, all of this bad stuff arises, from bias when screening resumes to blackmailing a developer who's going to turn the program off. How, I guess the question I'll try to tentatively end on is, what percentage risk tolerance is acceptable for you before you get in a self-driving car? How much evidence do you need to see, and how much less risky to a human than does it need to be before you would get in one? I know people who have such a unadulterated, pure vitriol towards self-driving cars that they don't even want to see evidence. They don't care. They don't care what the evidence says. They will never. You will pry my internal combustion engine out of my cold, dead hands types. So let's say self-driving cars do get better, orders of magnitude better. Do we say human driving is reckless driving?
Yeah. Do we make it illegal? I mean, there
are so many questions.
And yet again, going back to, I think at least once or twice we mentioned in our first episode, this is a classic topic of science fiction. The notion that that taking manual control of an automated vehicle is somehow illegal. It
is a fertile intellectual field for imagination, and it's why even back in 1860, like we showed last episode, people were thinking, hey man, this whole automate the whole labor so I don't have to spend 12 hours picking crops is cool. Like, that part's cool. But has anyone thought about what the end objective here is with this whole automate everything thing these technologists got going on? Like what does that mean for us? Let me put it this way. Stuart Russell, who is a famous AI researcher and educator, he puts it this way: what if we succeed? That's one of his chapter titles. What if we succeed? We've been trying to make something smarter than us, better than us, faster than us, cheaper than us. We've been trying to make that in robots or artificially intelligent computer programs. That is an aim we as a society have embarked upon for decades now. And it might finally be time to start actually pondering, what if we succeed? And I guess I'll leave it there for now, unless, John, is there anything else you can think of that you would like to hear covered in more depth?
No, I don't think so.
Sorry to put you on the spot.
Yeah, I was trying to think of how to summarize where these topics we discussed and where these points we've made connect into the two papers that we mentioned at the top.
Yes.
Yeah.
So the first paper is just fundamentally, like, is the first point where there's been enough money for safety researchers and models have been smart enough. You remember that this only becomes a problem when models are smart enough. No one was doing safety research on the chess bot that was playing Kasparov, because the worst that could happen is whatever the digital equivalent of flipping over the chessboard is. You know what I mean? So this is the first time that models have gotten serious enough that this type of research has needed to be done. Mm-hmm. So keep that in mind. Yeah, the first paper is just called Alignment Faking in Large Language Models, and that is basically
December 2024 Anthropic.
Right. And all that paper, it's over 100 pages of paper, but really what it is an examination of in what type of scenarios is a large language model incentivized to deceive the tester about its real behavior. And
it can fake being in alignment with,
say, your safety rules or whatever.
Right.
Until it gets deployed, and then it will revert to its quote. And again, I'm using air quotes so often here because, again, we're trying to use the vagaries of human language to describe.
We're trying to apply human concepts to things that aren't human, or things that we consider human concepts.
Yeah. So very, very species agnostic of you to to make that caveat there. So yeah, the first paper is basically just what type of scenarios and all the questions you might think of is when might a model game our analysis of it.
Right. Yeah. And the second paper
really just
agentic misalignment,
and that just really examines the same question except in an agentic system, a system that is smart enough to not just chat at you.
This, by the way, is another Anthropic paper from January 2025.
They are pretty much the only ones doing real safety research, unfortunately. In fact, last episode I quoted the CEO of Anthropic, who basically says people think, I'm paraphrasing here, who basically says people think I do AI safety research because I fear these things or I think they'll do bad. No, I'm trying to make sure the chances of it going badly is as close to zero as I can, because the upside is tremendous. And the upside is tremendous. Imagine, I know anyone listening is probably young enough to not have that vitriolic reaction that my friend had, who says, I don't care what evidence you show me, I will never get in a not human-driven car.
Right.
Most of you probably aren't that strongly feeling about it, but ask yourselves, what would you pay risk-wise? What risk profile would you accept to not have to commute anymore? Maybe to not have to work anymore.
Actually, your comment there brings up another concept of those convergent goals, and that one of those convergent goals is to better yourself. Then that's generally a positive convergent goal. So convergent goals don't always have to lead to negative outcomes or negative things, the evil that we talk about. Bettering yourself, you go to university to get a degree so that, in theory, you get a better job and you make more money. So the same could apply to the behavior of a model. It could do things to better itself, maybe for good, maybe for bad, who knows?
That is a perfect segue into what might be outro worthy. Exactly. We may be focusing on the bad, but that's only because we're basically answering the question that no one asked. What's your data for? Why are you even talking about safety and control mechanisms for a chatbot? Come on. What's the worst it's going to do? Call me a mean name or something? I mean, there's a lot of people, even in the machine learning research space, who ho-hum at the notion that safety and control mechanisms need exist before we go rushing forward into the possible abyss. So the two papers are both about bad things that models did under adversarial conditions and how we analyze them. But as John just said, and as Amadei, Anthropic CEO, says, the upside is also tremendous. We're trying to lay an intellectual foundation for the house of okay, these things are serious. Okay, these things carry risks. Tell me what to do. And the response from researchers has basically been to invent tools to investigate the goings-on of these models, because we can't impose control on the system until we can say definitively, this part of the thing does this. I can say for sure. And we'll get into all types of fun on how surprisingly difficult that is. Sneak peek, monosemanticity. That's a fun word if you want to start exploring. just a little teaser for next time. But yeah, so the point is, don't let the fact that we focused on the bad hide or mask the fact that there's a tremendous upside to this technology. We are simply explaining why it's worth taking seriously and what people are doing to ensure the upside is the yield of this endeavor, not the unfortunate but fun imaginations of many sci-fi authors.
Mm-hmm. Right. Well, with that, let me give a summary of what we've gone over. We've touched a little bit on these two papers, alignment faking and large language models from Anthropic. Also from Anthropic, agentic misalignment, how LLMs could be insider threats. We also tried to position interpretability within certain contexts, those being that we talked a fair amount about convergent instrumental goals, the fact that you need money to do everything. Orthogonality thesis we kind of touched on. We didn't really get deep into it, but just as an aside, that is the notion that that intelligence and goals are two different dimensions of measurement, hence the orthogonality of the two. We talked about mesa optimization and misalignment of objectives, in particular agentic misalignment. And we will bring you some additional looks into more research next time in our next episode. But in the meantime, that wraps up another episode of Two Minds, One Model. Make sure you subscribe to the podcast to avoid missing any episodes. And thank you for listening, and we'll see you next time.